All right, so we're going to start off a couple minutes early here with Eric Zimmerman talking about CAPE and easy tools and beyond.
Is there a clicker up here? Hello. So we got a lot to go through. So if parts of it seems like, wow, it was really fast, it is, right? So I would need more time to talk just about CAPE in a half hour, and I want to talk about some of the other forensic tools that are new in case you haven't seen them. I'll talk about two specifically, but before we get into those tools, I just want to, especially at this conference, this is a different conference than a lot of others. There's a lot of times more developers here, people willing to take someone else's code and bend it to their will. And so I want to point out and make clear that with the exception of some of the GUIs, right, even my graphical interfaces still are driven by underlying parsers. And so if you have a need for a registry parser, an event log parser, an MFT parser, a $J parser for the USN, those are available as standalone DLLs, where it will read the data, give you objects, and you do what you want with it. You're not bound to what I've given you or anything else. And so that's always important, I think, so that you can do your own thing. If the way that I've presented the data doesn't make sense to you, don't use it. Wrap it and use it. So you have at the top there, we have the concept of parsers. Take a binary file and give me out objects, lists, things like that. Wrap it in an interface. Now, I generally do a command line interface, and then, if it makes sense, a graphical interface. But as I talked about the last time I was here, any of those DLLs for the MFT or a linked file or a jump list, you can ingest directly into PowerShell and then do whatever you want with it. If you wanted one field or the last runtime for prefetch or the run count, just get those. You don't need to then parse CSVs and do all this other heavy lifting. And so from an output perspective, you're also not limited. I try to be flexible and give CSV and XML and JSON, but again, if you only want 3 things and not 27, there's always going to be a balance when you write some kind of a front-end tool. Go to the parsers and deal with those instead of trying to ingest the output of a command line tool, if you have that need, okay? Now, some of the newer programs that I've written, probably the newest one, I think that there's one up there that I'll talk about for a second that isn't mentioned, but EVTX ECMD, that's the event log parser, and then MFT ECMD, which is really more of a generic NTFS artifact parser than the MFT specifically. The other things that I've been doing is moving the parsers away from, well, just go to GitHub and download it and build it. I'm making NuGet packages. So it's as simple as searching for it in NuGet and then updates and everything else. If you're familiar with the Microsoft Visual Studio ecosystem, updates just happen, kind of a thing. You just say, update the package, you get the new thing, and everything's great. Much easier than the way I was doing it. I don't know why I waited so long, even for my own development. Much easier. And then finally, and if you're not too in tune with, again, the Microsoft ecosystem, they have been driving significantly toward what's called .NET Core, which is basically going to be cross-platform everything. Not WinForms and GUI stuff, but from a command line perspective, what does that mean? It means that my code is going to be much easier to run anywhere. You want to compile it on a Mac or on Linux, go for it. There's no Windows or Wine or any of this other emulation type stuff. So if that's the kind of thing that you want to do, you can do that. My other goal with .NET Core is going to be to try to get completely standalone executables for Windows, which means you don't need .NET at all. That's one of the newer things as well, where everything gets packaged into the executable. The downside being, it's going to be a bigger executable. The upside being, it doesn't matter what you run it on, you're good to go. So those kinds of things are coming. .NET Core's finalized-ish now, so you'll see me doing a bunch of stuff there. It might be completely transparent to you as an end user, but again, getting into that, well, I want to deploy this stuff differently in my organization, that will make your life easier, especially if you're a Linux shop or something else where you're automating and doing a lot of these other things. So let's talk a little bit about the tools, and then when we're done with these 2 tools, I'll briefly mention another one. Then we're going to switch gears into talking specifically about CAPE. So EVTX ECMD is my take on an event log parser. Now, event log parsers have been around for a long time. In my opinion, the problem with event logs is it's very hard to standardize and normalize output. Every single payload in an event is completely different. You might have 5 fields, 2 fields, 58 fields. How do you take that and normalize it into something meaningful? A CSV, for example, and I don't have 287 columns that sometimes they're mostly empty, right? People shaking your head, that's, yeah, nodding, like that's the problem. So how do we fix that? Well, I think that I've come up with a way to do it, and my concept revolves around maps. And so basically, I've come up with a way to normalize CSV output regardless of the event. And I've already done a bunch of maps, but again, the other thing that I like to do, you shouldn't have to rely on me to make changes and drive things that make sense to your organization versus how I think. And so maps are a way that you can do whatever you want to do with event logs to extract out the data that's meaningful to you. Plus, you can do event inclusion and exclusion. In most cases, there's only, a couple dozen event logs that most people are at least going to focus on initially. Why do I want to look at the other hundreds of them potentially and just add noise into my data? And so maps is what's going to solve that problem for us. Now, why do you want to use a map? Well, the easiest thing is it's customizable. And I've done, whatever your favorite event ID is, there's probably already a map in there for it. So your 4624s and all your PowerShell and your process auditing, all that stuff's in there. RDP, service creation, everything's done. I think there's almost 90 maps that are in there right now. So the idea here is, and you can see if I can get the zoom going on here. Nope, that's not going to work. Over here, it's kind of small, but you can see once you have maps and you've processed your event logs, you don't need to worry about, well, I need to remember 37 different event IDs. All you need to group by is the map description, and answers start falling on the floor for you. What do you want to know in investigation? I want to know who logged in. I want to know what services were created. I want to know about scheduled tasks that ran. All you have to do is find that particular map category, and everything else is going to be available underneath it. So it's basically instantaneous answers for anything event logs. Now, you're going to need to get the event logs back and run them and dump them into either CSV. It also supports JSON with the same normalization to throw into a SIM or SoftElk or Splunk or whatever else you want. Why is that nice? Because I'm not doing free-form searching anymore. I'm searching on specific columns and values, which is going to make your life a lot easier instead of wading through it and trying to find a meaningful string in a giant blob of JSON 1,000 characters wide. Okay? So the maps are very straightforward, and like my other tools, it does a very good job of showing you what it's doing, and if there's any errors, it's very clear about that, when it failed or it couldn't fail, and so on. Now, this is an example of what a map might look like. Again, not the biggest thing, but the PowerPoint presentation will be available if you want to get this afterward, and you can see exactly what's going on. So on the left, we have basically the XML payload. Now, I do some niceties when I process this stuff and getting rid of namespaces and some other things that make this more painful to deal with. But the idea here is that we use simple XPath queries to map from the source, the raw XML, which is what the EVTX files under the hood are anyway, into normalized data. Now, I use YAML configuration files, simple plain text files, that define values that get then rolled up into properties. So you can define, regardless of the XML that's in an event log, you can define simple XPath queries, assign them into variables, and then use those variables to assign them to properties. This is how you're able to get rid of all the noise, focus on the signal that makes the most sense to you, and then get things out, as you can see at the bottom there, in a very meaningful way. Who's logging in? What are the remote IPs? When did it happen? Very, very succinct information across a wide range of event logs. You don't need to open up 15 event logs in 15 different tabs. Single file, all your event logs, relevant, normalized in one place. And you also get the JSON of the raw event as well, which means if you're doing a free-form keyword search and you didn't map it, you're still going to get that hit to be able to drive down into the value and find your answer. This is just an example of some quick wins. So I've got some creative sorting going on here. So I've grouped by map description and then several of the payload fields and then the remote host. But what we're seeing here is the successful logins for each username by logon type, network, interactive, RDP, and then by remote host. And so now from a pivoting perspective, from an IR lateral movement perspective, I could see where it's coming from, what the times were, who's doing it, what types they are, very, very quickly. I don't have to go and look at 10 different places. This information, depending on how you have things grouped and sorted, might have come from 2-3 different event logs, sysmon, security system, whatever. It's all going to get normalized based on how those map fields get pulled in and set. So if you haven't seen this, give it a whirl. And again, if you want to extend this or add it or tweak it, the maps are just plain text. You change it, you run it, it's going to reflect your changes immediately. If you do come up with interesting maps, please do a PR back into the GitHub repo, because there's a built-in sync functionality that will pull down new maps or updates. so that everybody else can benefit. There's no manual processing involved. Obviously, you have to be on the internet, but that's about it. Now, from the MFT, this program is going to handle MFT, $J, boot, SDS, and so on. I haven't dealt with log file yet because it's horrible, but we'll get there eventually. You still can do all of your CSV, JSON, even body file if you wanted that. The CSV file has a bunch of helper stuff. So if you want to know about files that have an ADS, an alternate data stream, you could do that pretty much instantly. Or files that are basically an ADS inside of it. Directories, in use, copied, time stomping, all of those things are going to be built in. There's also iStat and FLS emulation mode, if you will. So if you're familiar with those tools and you run them against an image, you can do more or less the same thing with a standalone MFT. These are just loose MFT. This tool handles these files loose. You wouldn't point this at an E01 or a DD, for example. I want the raw file. Doesn't matter if it's in use or not. If you run the tools as an admin, it will deal with the files being locked, do raw disk reads, extract stuff out. They can also handle volume shadow copies with a single switch. So there is no symlink, mounting, this and that. You just say tac VSS, and it will go through and dedupe, normalize everything across all the shadow copies as well. I've done a lot of work in pulling out extended attributes, and those can become pretty interesting when you're looking at files that have been signed or validated by Microsoft. Do they have certain extended attributes and so on? And then for resident files, of course, that data is in the MFT. So I will actually show you the payload of the resident files directly in the output so that you don't need to go do that somewhere else. If you want to look at zone identifiers or whatever, it's all right in the payload, the output. So just some examples here. You can see at the top there what the CSV might look like. Now, one approach that I take that's a little bit different than other tools, you'll notice with the timestamps, you've got your created and your file name and so on from the standard information file name rather. But notice that second column for the timestamps is blank. Now that doesn't mean there's not a time there, but what it means is that the file name created time is exactly the same as the standard information. That's useful for several things, saving you space in your CSV and letting your eye key in on where the file time does not match the standard information. Much, much, much easier to do than having, you can imagine all that duplicative data, and it's mostly duplicative normally. So there's an example where one of them is starting to jump out. So you see there's some things like that. You can turn that off if you want, but again, I try to do sane defaults to give you the most beneficial thing that you can out of the box. At the bottom is an example of seeing the resident data. So there's the zone identifier, and it dumps it out as ASCII and Unicode. Obviously, if it's not stored in Unicode, you get what you see there. But this is nice because I don't have to go to another tool or go try and figure out what's in there. It's all going to show up in the CSV. So again, from that quick win perspective, zone identifier, zone ID equals 3, there's all my stuff that came from the internet, I'm out. If that's the kind of question you want to know. More examples here. You can see this is dumping an SDS file. So if you wanted to know about all of the security on a given file, one of the things in the output will be the security ID. You'd pass that into with $SDS, and you'd get out all the ACLs and DACLs and the security permissions for any given file. That stuff does not live in the MFT. There's just a pointer into the $SDS file. It can handle both of those for you. And then finally, you can see the FLS, the directory listing type stuff there. So if you wanted to dump stuff out like you would see with iStat, you can do that as well based on the inode or the entry number, whatever you want to do. Now, before we switch gears here and I talk about this last part, the other one that I don't have time to talk about is RECMD, which is Registry Explorer command line version. If you've not used this, specifically as it relates to batch mode, I think you're missing out on stuff. From a scaling perspective, from finding things in an automated fashion extremely quickly to what's relevant to your case, RECMD is going to be hard to beat. It also has kind of solved the problem of how do you normalize registry data. It will do that as well. It understands how to run all the plugins from Registry Explorer. So there's also extensive batch file examples, including ones that are in heavy use in Azure that Troy Larson has designed and allowed us to include in the repository. So that's another one. If you haven't seen that, I would recommend that you check out. Now, the tools, and more of the tools are going this way. I don't want them to just be live response or deadbox. You should be able to be flexible and run them both ways. And so you're not just dealing with deadbox files here where you extract out these files and then run them on your own system. You can do it live. So if you do this, you obviously need admin, but from there it will handle all of the locking and shadow copy access and everything else without you having to do anything. There's no mounting things. So if you're starting with an E01 or on a live system, it will handle all of these things for you. Now, as we'll see with CAPE in a minute, that front-end collection part will do all that for us, and then we're just dealing with offline dead box files from that point. But more and more of my tools, I want them to be able to run in a live environment so that it's not that I got to pull everything back and then do this. It just makes our lives a lot easier. Now, switching gears into, well, what's CAPE and how do we do that? We'll talk about what it is here in a minute, but before we talk about that, even with the few things that I've just talked about, the problem, and you can see there's some things up here, there's a lot of tools. I have tools, other people have tools, there are these 15 different command line programs that you want to run all the time. If they're all my tools, they might be relatively similar from a switch perspective. But somebody else writes them and they use a different, they spell out DIR or something else. It's all different. Well, now you have to remember all those and not make mistakes I misspelled something or I forgot a space. It becomes difficult to keep all of that stuff in check, right? So from a consistency perspective, it becomes very hard to deal with. Now, some of the other things that you run across is just the output might be different. So one tool might present data one way, another tool might present data another way, but think up a level from what these tools are doing. If we think categorically, evidence of execution as opposed to prefetch or shim cache or AM cache. Well, I can group more individual tools that deal with those things into a category and then potentially group the output into those categories. That makes my life a little bit easier from an investigator. I might not have ever even heard of AM cache. But if I just think to myself, I want to deal with and locate evidence of execution artifacts, well, now I can focus in on a category of behavior and then look at the output because it's all going to be grouped in that particular output folder. We'll see what that looks like here in a minute. And then the other part is, well, if you have 5 different people doing the same process that's supposed to be standardized and they do it in a different order, or they forget a switch, or I just forgot to run that program this time, it becomes very hard to be consistent. And so some of these problems, as well as some of the work that I've done in the past when I was at the FBI with OS Triage, is how do we go about getting good data out of systems quickly to move the ball forward? Now, one of the things that we're not going to be doing here, and I'm not saying, is, well, you should just not do E01s. There's no more need for full disk images anymore. Just don't do them. Now, that may be the case. It depends on who you work for, your processes, your legal requirements. Is law enforcement ever going to get away from making an E01? Probably no. But if you don't need to pull back an E01, why? Why would you? Now, the other part of it is, and think to yourself, what percentage of the files on a system, even if you were given a full E01, are you going to look at? Is it 80%? Is it 8%? Is it 1 to 2%? It's probably closer to 1 to 2%. So why do you want to spend 4 hours imaging instead of 40 seconds pulling the files you're going to look at anyway and move the ball forward? That's what I'm saying. I'm saying insert the process that I'm about to talk about before your image, if you need to do a full forensic image, or as part of that threat hunting, let's go out and let the registry, something's weird here, let's look for persistence, pull back some registry hives, do some work. Okay? So it's a means to go out and do targeted triage collection of what makes sense in your particular case. Now, CAPE is my solution for this. If you're familiar with OS Triage, you might think of this like OS Triage version 4 or something like that. This is not a frontline investigator tool where you're going to take somebody that was just working a different violation and stick this in and run this in the field. This is going to be more for a forensic examiner, somebody who's a little bit more seasoned and knows what they're looking for. I want to look at prefetch. I want to look at shim cache. I want to look at link files and see who was opening stuff, when they opened it, was peer-to-peer software run, whatever that is. This is going to allow you to be able to search various things, collect that data, and then if you want, process it. You do not have to process anything that CAPE collects. It's an option. Now, why is that nice? Collect, process, examine. That's the flow. I don't have to worry about the first 2 steps other than to run a standardized process. Then I'm just looking at my output, CSVs, whatever. Now, how does this stuff all start getting tied together? Well, we're going to see examples of that, how we could build what I call tool chains here in a minute. Now, from a why perspective, it's a lot of the same reasons I've already been discussing, so we don't have a whole lot more to say here, other than it's customizable. In fact, if I just gave you cape.exe by itself, it's stupid. It doesn't know how to do anything. It just sits there until you give it targets or modules. Targets define what to collect, modules define what to process, what to run. And so from that perspective, you get to make the decision on what it's going to collect, where it's going to look, how you're going to run it, what you collect at any given time. Is it just link files? Is it just the registry? Is it the file system artifacts? You get to choose one or more or all. Now, just because you can do something doesn't mean you should. Collecting everything just because isn't always the right answer, and it's certainly going to take longer. So you get to make the decisions on how you build these things. That's what I'm talking about at the end there with these tool chains. So let's take a look here about what exactly that's going to look like. CAPE is going to allow us to basically glue all of our processing stuff together. What do I want to get? How do I want to process it to do my analysis in a very quick fashion? So a tool chain is basically a set of targets and modules. Again, targets collect files, modules run command line tools that we can group together. And if you are the person doing this, or if there's a senior person in your organization that says, this is our standard for this type of a case, this is what we always get, and it's going to answer 80% of our questions, that's a good thing to have. And then if you need to pivot into another specific thing, like we only want to know about QuickBooks files, well, then you might have to go back and pull something else off depending on what you find. Who's opening up things based on link files and shell bags and whatnot. Okay? So we want things to be thorough, repeatable, scalable. It's easy to do this on one machine. We want to be able to do this at scale. And then we want to have audible. We want it to be consistent and show how we're interacting with these systems. So how do we go about building these? Well, I came up with this kind of silly thing, think DFIR. So determine what you want, fabricate your targets and modules, run them, invoke it, and then review it. Look at your output, figure out what you need to ask, what questions you already have on your mind, go find the answers. And then you just would pivot on each machine that you need to from a lateral movement, or it depends on your case, right? You could do this at scale as well, which I'll talk about a little bit at the end. Now, as far as a few examples, and again, I would normally do demos and all these other things. I just don't have time to do that. But let's say you want event logs, file system related data, and you want CSV, and then you're going to load it into Timeline Explorer. Well, that process would look like the command line at the bottom. Now, there's a CAPE in it of itself is a command line tool, but I wrote a graphical tool called GCAPE that, as you interact with it, builds a command line. So that way you don't have to sit there and go, well, did I misspell that? Oh, I put a space there. All you do is pick stuff from menus. It builds the command line. Once you have a working command line, you're like, that's amazing. I don't want to have to do that every time in the GUI. Copy, paste the command line, and now you're automating. And there's batch mode and all these other things that you could do to make this scale as big as you want. Okay, so and the documentation is all out there as well with a lot of these things. If it's like, that sounds interesting, I would encourage you to go check out those things as well to be able to see exactly what that looks like. So from the collection perspective, here is where you now need to start deciding what you want. And in this example, we have two, but that could have also been extended out to anything else that you've ever heard of. I want browser history. I want browser extensions. Now, the collection piece is going to be the raw files right off the system. It's going to be the event logs. It's going to be $MFT. It's going to be the registry hives. All copied back, all forensically preserved as far as timestamps and directory structure, all of the source SHAs, deduped by SHA. So you're not going to be getting back 10 copies of the same file, unless you want to. You can turn that off. But by default, it's going to dedupe for you and keep audit trails of everything that it's doing. Now in this particular case, we're just going to be dumping out all the files to another directory. Source machine, directory. The directory can be on the same system. Not best case, but if I'm just going out looking for something, maybe I do it that way. I could write to a UNC share, I could write to SFTP or S3, all kind of different options from an export perspective. As we'll see in a minute, the other thing I could do is write to containers, and I'll talk a little bit about those when we see the next example. And then finally at the end there, after you process, we run, in this case, EVTX ECMD, we run MFT ECMD. Well, I don't need to worry about anything other than saying, hey, CAPE, collect and process these two things. I'm going to end up with CSVs that I can load into Timeline Explorer, pull into Splunk or whatever else you want, and start answering questions. Okay? So from a very consistent format. Now, this is the same exact command, but we've added volume shadow copies. And notice how drastic of a command line difference is. We just add the VSS switch. That's all you need to do, and CAPE will automatically discover, mount, and give you raw access to all the shadow copies. It is not the symlink method. So if you're familiar with that, the make link, or if you've used my VSC mount where it does the make link, and that's basically not going to get you special file system files, $MFT, $J, and so on. The CAPE will do a raw disk read into the shadow copy volume and extract out everything. It's completely transparent. So in this case, we want the same exact stuff, but I want to go back in time a little bit more. If you're familiar with shadow copies, pull all of that data out. Everything else just works. All of the source and destination it's going to map out the fact that it came from shadow copy 1 or 9 or whatever. Everything is going to be logged in that perspective. You're also going to get I'll talk about containers here in a minute, but you're also going to get a list of all the files that were successfully copied, as well as a list of all the files that were skipped, which is important, right? I don't want to just guess and not know why a file didn't come out. It's going to tell you that it was deduped based on the SHA-1. It was exactly the same. It's going to tell you, you can also whitelist with CAPE. So if you have a list of 80 million SHA-1s from a bunch of known good data, you don't even have to collect those up front. Troy Larson at Microsoft, I mentioned him earlier, he uses this a lot for his back-end processing, and he cut his processing down from like 4 hours to about 38 minutes by using that dedupe functionality up front. So in those cases, it would tell you that it was skipped because it was skipped because it was ingested as far as the deduping feature up front, not because it was a skip based on the same file, same hash for any two files. Now in this case, we've switched it up slightly. I don't want the previous things that I'm looking for. Maybe in this case, I'm more interested in, I want to know about documents that were opened and folders that have been visited, right? I could do some shell bag stuff. So in this case, I want linked files and jump lists and registry hives. Now you could target system hives versus user hives or both. There's compound modules as well and targets that will run multiple things. Now in this case, I'm doing a preservation. So this you could think of like any other container you're familiar with, an 81, or a container in X-Ways, whatever it is, you can throw all this stuff in there, and now you have a self-contained, by default it's going to get zipped, copy of your original evidence. Treat that as your original evidence. If you need to work on that evidence, you extract out a copy of your VHD or VHDX, do your stuff, and your original is always preserved. All the original files, timestamps, nothing is going to change. If your forensic tool of choice understands VHD or VHDX, pull it right in, you don't have to do anything, and you can just start looking at those particular files. Again, I'm only going to be looking at that 1 to 2%, and maybe even 0.1% if you're more focused like this, than that whole E01. So from a post-process perspective, it's going to be almost instantaneous. And I say, 40 seconds, that's probably more than enough time to do something like this, by maybe 10. It just depends on your system. So the container options are going to be VHD, VHDX, and zip. So if you just want straight up zip and then you'd unzip it, it's not preserved in that kind of wrapper, you could do that as well. When you're using the containers, you can shove that out to Azure Storage, S3, SFTP. CAPE also has a built-in SFTP server, so you don't need to worry about standing up a Linux box or something else. Start a copy of CAPE with a config. It's going to give you all the IPs and the usernames you have defined. You could do jailing and read-write and all these different things. And then it's going to tell you all the IPs on that box. Then you just copy-paste the commands. And now you could SFTP across from all the other machines in your environment. Why do I like that way? Because when you're done, you just kill the main CAPE interface that's running the SFTP server, and it's gone. There's nothing for anybody to discover later or anything like that they might be able to get on and so on. So lots of various ways to interact with it, depending, again, on your needs. Now, this is an example of what the container might look like. So it's kind of hard to see here, again, just because of the color. But that collect only and writing everything out to that container took 15.6 seconds. That's to build it, dedupe, build the VHD, copy it all in, all the normalization and auditing, and then we're sitting there with that particular file. I have a 45 meg file now that I need to worry about moving around. That has all my evidence in it. If you do SFTP things up or transfer it, it's going to be tagged based on the computer name where the data came from. So if you did a collection of 100 things, it's going to have all the machine names on your collector, and you'll know what's there. Now, the last few things that I want to talk about here, I think I might have about 4 minutes left here, 4 or 5 minutes, and I want to give some time for questions if you have it. One of the things that's very important for us, as I mentioned before, is, yeah, this is great, but I don't deal with 3 machines at a time. I deal with 3,000 or 30,000. How do I do this in slightly bigger pieces? Well, you can already call CAPE using any endpoint that you want, such as Carbon Black, Falcon, Tanium. Within a few days, I released this on February 14th, and by that weekend, people at Blue Cross Blue Shield had already figured out how to have Carbon Black calling this at scale in their environment. Now, they, based on their needs, had some, hey, we're doing things a little different, blah, blah, blah. Can you tweak it so that it works better for us? Yeah, absolutely. In fact, those are better ideas from a design perspective anyway. I make changes. So if you come up with, it's this close to being, it'll work for me, just tell me. And if anybody's ever emailed me or dealt with me or reported a bug, generally pretty responsive in getting stuff in there and fixed, happy to do it, right? Why? Moving the ball forward for everybody. If you think it and you're dealing with it, somebody else probably could benefit from the same kind of thing. PowerShell, of course, will work for you as well. If there's things like Kanza that can do these things already from a framework perspective. But we already have, and people have come up with kind of one-off things, but now Carlos and Mark, they have already come up with frameworks, if you will, or methodologies to do this. Carlos just released his blog post, I think, this past weekend, that will walk you through setting up Cape on a web server somewhere, and then everything gets automated. List of targets, you just run it, it does it in parallel, pulls everything back. So if you have one of those fancy endpoint systems, wonderful. You could use the exec, if you're familiar with Carbon Black, exec taco, do the Cape thing, it's gonna come back and pull what you want. If you wanna do it with PowerShell, you can do it in a more one-off type fashion. Why is that nice? It's a simple one-liner. On this system, run this command, it's gonna download Cape, unzip Cape, run Cape, push the data out, delete Cape, and it's over. Now, if you're doing that at scale over and over and over, where you're like, maybe you leave Cape there, right? So tailor it. You're talking maybe 5 meg zip file to be able to push around to do whatever targeted collection that you want. So we're not talking these giant, if you're gonna do this, don't push gcape around, because that's like 70 meg, because it's a GUI. Get rid of that, you're not gonna be doing that on endpoints anyway, okay? So lots of different ways to make this scaled, again, depending on your environment. So if you have something where it's like, well, how would we do it with this? I can certainly help accommodate any kind of more advanced or different use cases than what we already have solved. I think Falcon is documented in the Cape docs. The other ones are going to be very similar to that. And then the PowerShell stuff is going to be documented and pulled in from Carlos's blog. I think it's mashthatkey.com. He just did it. But I'll have a reference to that on the site as well. So with that, I wanted to leave a couple minutes, which is about all I have left. 5 minutes, so that's perfect timing, to be able to see if there's any questions out there. I don't know if people have used it or not used it, or based on what you're seeing here, yeah, but can it, kind of a thing. I'm happy to answer any of those questions about Cape or any of the other stuff I talked about. I don't care, whatever it is. Otherwise, I'll return my remaining time to the next group, and they can get set up. Going once. Twice. All right, I think that's it. Thank you.